Now let's think about in terms of quadratic function. Y is equal to ax squared plus bx plus c's minimum value. And as we have learned in the few videos, the minimum value, at first in order to do that, we need to convert it into a vertex form. The reason is because we cannot graph this function with this form ax squared plus bx plus c because we don't know a minimum or maximum value which can be a vertex of a quadratic function. So all you have to do is convert into a vertex form. That is the case that we did right over here. So if we convert it into a vertex form, it will going to be vertex form is y is equal to a times x minus p squared plus q, where a defines a value of a function's format if the a is greater than 0, which means when the a is positive, the graph will go downward, will go upward. And when the a value is less than 0, the graph will go upward, will go downward. So this is a case that we have learned in the last few videos. The a doesn't really affect when it comes to graphing a parabola, but the only thing that it affects is a format of a parabola, whether it goes upward or a downward. So let's think about when the a is greater than 0, which means the a is positive, and as we have learned here, the graph will go upward like this. That means the graph will keep going on, and it only a maximum point does not exist, and only a minimum point will be right over here. And so if you talk about a minimum value, which is will going to be vertex, and then it is a case when the a value is greater than 0. So let's think about that case. We have thought about it when the a value is greater than 0, which means when the graph will go upward, only a minimum point will gonna exist in our graph. And if you think about our vertex form, in order to find a vertex, which means the x comma y, the coordinate, the x value is a case which makes this whole expression turn to 0, and the leftover will going to be y value, and it is right now going to be q. So all you have to do is find the value, and a y value is also q, so I will convert it as q. So if you think about it, the x value will, if you input x into p, it will going to be a, so it will going to be a, and then p minus p, we inputted x value as p, and then square plus q, and that should be equal to y. And then this term will cancel out as 1, we get q is equal to y. So we figure out that coordinate is p comma q. And right now we figure out it not exact value but for it. This is the way how we find a vertexes, through our vertex form. So if we actually graph it, think about in terms of graph of this vertex form, and if I show it in an approximate value, it will going to be something that look like this. And this is an approximate value of ax squared plus bx plus c when the a value is greater than 0. So we can obviously see that the graph is going upward. And the maximum point never exists because the graph is still keep going. And the only minimum point exists, and the minimum point as we have cp comma q. And we can also see that p is a value of the x value, and we can also see it right over here. It is in the x-axis, which means it is a x value. We can write it as p, and the y value it will going to be a q. So this is our minimum point of our graph. And let's think about actual example, like substituting numbers into ax squared plus bx plus c form so that we figure out an exact value of the graphs. Let's think about the example as x squared plus 4x plus 5. And if you think about it, as we have learned right over here how to make a perfect square, all you have to carry is a x terms. So I'm going to put parentheses in the x term, x squared plus 4x, and I'll leave some spaces and I'll write plus 4 plus 5. Now, in order to make perfect square, there is a formula for it. In order to find an unknown quantity that I'm pointing out, we are multiplying half of a x terms, which is going to be 4, and then square it. If you do that, it will going to be 1 over 2 times 4 will going to be 2, and then square will going to be 4. But if you think about it, we just added 4, and we also need to subtract 4. So I'll write subtract 4. So in this case, it will going to be x squared plus 4x plus 4, and we take minus 4 to the outside, and they are going to be plus 5 and then minus 4, which will just cancel out as 1. And if you think about this term right over here, it clearly factors out. If you think about in terms of binomial theorem, x times x makes x squared. And then if you multiply these two numbers, we will going to get 4. And if you add it, we'll also get 4. So we can think about it in terms of a factor of a 4, which is at first 1 times 4 and then 2 times 2. But if we add it, we will going to get positive 4x. So if we add 1 and a 4, it will going to give us 5, which is not equal to 4. And if we add 2 and a 2, it will going to give us 4, which is clearly equal to 4. So we can write plus 2 and a plus 2. And we need to bring our 1 down. So plus 1. And then for this term, x plus 2 times x plus 2, we're multiplying same term, so we can cancel it out as x plus 2 squared, and then we bring our 1 plus 1. And this is clearly our vertex form. And if we actually graph it with these points, we know a value of it, and we know a value of the a, which will going to be 1, so the graph will go upward. And we can think about it in terms of minimum point. The reason is because, as we have learned here, if a term is positive, the graph will go upward, and it will only contain a minimum point. So for the minimum point, the x value is the case which makes this whole expression turn to 0, which means when you input a value of -2, this whole things turn out to 0, and the left over will going to be y value, which means we input a value of -2, and our left over will going to be positive 1. So this is our minimum point for it. So let's actually graph our graph. Graph the point -2, 1, which means the x value is -2 and the y value is positive 1. When the x value is -2, the y value is positive 1, which means this term will going to be our minimum point of our graph. And let's input some values of our points. X plus 2 squared plus 1, that is equal to y. At first, let's input a value of positive -1. So if we erase this thing a little bit for our spaces, at first if we input a -1 to the x value, it will going to be -1 plus 2 squared plus 1 will going to be y, which means this term turned to 1. Squared will going to be 1 plus we got 1 more, we get 2. So if you input -1 as x value, the y value will turn to -1 comma 2. So -1 comma 2. So let's find one more point. So at this time, let's input a value of -3. If you input a value of -3, we're going to be -3 plus 2 squared plus 1, that is equal to y. Then this term turns to -1, but squared will turn into 1 plus 1 will turn into positive 2. So if you input a value of -3, we're going to get positive 2. -3, positive 2, right over here. And we can actually think about the basic format of a graph, which will going to be approximate value of a graph, and that graph should satisfy this whole equation, which means they should all pass these points that we picked. And this will going to be our function, our vertex form, x plus 2 squared plus 1. And let's think about it in terms of one more example where a, which is a coefficient of the x squared term, is equal to 1, not equal to 1.